Today is May 16, 2011. You guys are on textbook page 353, Blue Notebook page 410. We're on lesson 7.3. I wanted you guys to copy down slope angle and tangent of an angle. Today we are going to be learning about the tangent ratio. We're going to cover 3 ratios of this type, okay? First of all, what's very important to learn is this ratio we're going to cover only works with right-angled triangles, okay? So we're talking about right-angled triangles. The very first thing we're going to do is we're going to learn how to name these triangles. So, the very first thing we're going to learn is hypotenuse of a right-angled triangle. Anyone know what it is? Okay, I'm going to name these just so we can refer to it by name, okay? So we'll call this triangle A. Oh, there's something wrong with the tablet. B, C. Okay. Where is the hypotenuse? AC. Very good. AC is it UES? No. EUS? USC. Is that right? Okay. Hypotenuse of a right angle triangle is always opposite of the right angle. Okay? So I'm going to quickly make 2 more right angle triangles. I'm going to turn them. We're going to call these ones, we'll give them different names. We'll call it D, E, F, and H, I, J. Where would the hypotenuse of these triangles be? DE and IJ. Very good, okay? Hypotenuse, hypotenuse, hypotenuse. You need to be able to find where the hypotenuse is of a right angle triangle because it's going to become very important when trying to solve this ratio. So I'll finally give you the ratio now. You guys seen this on your calculators before. What this says is tangent. Okay? Now, what do they use as angle? They don't use theta, I don't think. Oh, they do. They use theta. Okay. It says tan theta. Theta refers to an angle is equal to the opposite side divided by the adjacent side. Okay? Opposite side divided by the adjacent side. So, let's put up another right angle triangle. Let's do tangent in green. Okay? Theta refers to an angle. So let's say I'm referring to this angle here of our A, B, C. I'm referring to my angle A. Okay? That's my theta. So I need to solve for this. I don't know what it is. We're going to call it theta. Think of it like x. It's a variable. The ratio says tangent theta, so tan, whatever that angle is equal to the opposite side. What side would be the opposite side of this triangle, of that angle? Which is it? BC is opposite. So here's our angle. We're in this corner. BC is opposite of that angle. So we're going to call that our opposite side. And does anyone know what adjacent means? Duke? Sure. by deduction, you guys already know where the hypotenuse of this is. Adjacent means the touching side, the side touching that angle, okay? Now, technically, there are two sides touching this angle, right? We have this side, AC, and we have AB. But luckily, we already have the name of one of them. What is AC? AC is our hypotenuse. Hypotenuse is always a hypotenuse. It will never be an opposite side. It'll never be an adjacent side. It's always called the hypotenuse. So as long as you know where the hypotenuse is, you know the other side of the triangle that touches is considered the adjacent side. Okay? So this is our adjacent side. Okay? You know what? Maybe we'll give some color to these. We'll call opposite red always. Adjacent could be blue. Which means the only other side of this is our hypotenuse. I'll give it an H. Now let's say, this is where it becomes not difficult. This is where most people screw up. I have my right angle triangle. I'm going to rename it the exact same thing. It's going to be called triangle ABC. But this time, I'm going to call this angle here theta. That's going to be my theta. I'm trying to solve for that angle. Okay? So, what is my opposite side in this case? AB. My opposite side changes. Adjacent and opposite change depending on what angle we're trying to find. So since this is the angle, like we said, that we're trying to find right here, our opposite side is going to be AB. Now AC is still what? Hypotenuse. Still the hypotenuse, which leaves by deduction the other side that's touching this angle, the adjacent, BC. So if you guys have noticed, I use the exact same triangle, exact same name, but the opposite side and the adjacent side can both change. It depends on what angle I'm trying to find. Okay. So we've done that. We can now name a triangle. Very, very, very important for what we're going to do. So let's actually deal with the question. Okay. So here we have an actual question. We'll call it our example 1. Okay. And okay. So here we go. We have a question. They're asking us in this question to solve for theta. That means they want this angle here. Okay? I only know one ratio, which I've just showed you guys. It's called tangent ratio. And I've been told that tangent theta is equal to, what is it? Opposite. I'm going to represent it with O. Let's put it in red so you guys know. Opposite divided by adjacent. Good. And adjacent was in blue. So we'll go OA. And what they're referring to is the length of those sides of the triangle. So the very first thing I'm going to do is opposite. What is opposite of this theta angle here? What side? CB. CB is opposite. This is my opposite. So O is going to be what? 5. We already have that part. Okay, let's get the other part here. Tangent theta is equal to 5 divided by the adjacent now. Now the adjacent means side touching, but there's two sides touching. Which one are they referring to? AC. They're referring to this side here, okay? Because it's not the hypotenuse. That's our adjacent, so A is going to be 12. Beautiful. You already got that down. So they're saying that tangent theta, so tangent this angle, is equal to 5 divided by 12. Okay? Let's figure that out. Let's figure that out. Okay, so once again, we said tangent theta is equal to 5 divided by 12. Very simple. 5 divided by 12. I really hope you already know how to do that in a calculator. If not, this will be challenging. tangent theta is equal to 0.41, and let's just call it 67. Okay, we'll round it a little. So we have that ratio. Right? So we've discovered what the ratio is. We've already solved for it. Now in the book, they really don't get to this till later, but we're going to do this in 2 examples because we can. Now I'm going to show you actually the hard example first, how to solve for the angle. I need you to think of this tan actually represents an equation, okay? And theta is a number that we're putting into an equation. So think of them as 2 separate identities, okay? Tangent can move. I'm only trying to find theta. I'm not trying to find tan theta. So I actually have to move tan to the other side of the equation. Think of it like just like in algebra, okay? So when tan moves to the other side of the equation, I will show you all the steps to it later. But essentially, this is what it's going to look like when you move tan. Because we're trying to find theta, tan becomes tan to the -1. It's called inverse. You have it on your calculator, it'll be like a second function thing. So tan -1, 0.4167. Okay? This is how you're going to solve it on your calculator. So let's try it right now. I look on my calculator, I see that I have tan. But see, that's tan, just the regular one, without the inverse. That is not the one I want. I'm most likely going to have to push second function, tan. See how it gave me that -1? Then I'm going to type in 0.4167. I write that right? Good. Make sure your calculator is in degrees. If your mode says RAD, you will not have gotten that number. That number is theta is equal to 22.6. That's degrees. So it's saying theta is 22.6 degrees. If you need to change it, you go to something called mode. Okay? Yours won't look like mine, but if you notice, one says radian, one says degree. I'm in degree. You need to be in degree. Figure it out. Every calculator is different. We're going to call this example number 2. I've named the triangle very similar. ACB, ABC. The numbers are different. We're also looking for a different angle. My angle is down here now. I'm looking for essentially angle B. Which side is my opposite side? AC. So that means the opposite is going to be what measurement? Good. And my adjacent, in this case, will be what? BC or CB, 4.5. It's touching, but it's not the hypotenuse. The hypotenuse is always the longest side. So that's another way to find hypotenuse. It is the longest side of a triangle. So I'm going to plug those values in. They were 6.8. What? Oh. 6.8 and 4.5. Okay? Exact same idea. Tangent theta is equal to 6.8 divided by 4.5. Let's put that in our calculator. 6.8 divide 4.5 equals 1.5, 1 repeated. So I'm just going to put 1.51. The less you round, the more accurate it becomes. 2, 3 decimal places is always good with me, okay? So I have tangent theta equals 1.51. But once again, I'm trying to solve for just theta. I need just theta. So I got to isolate it. I need to tan to the other side of the equation. So it's going to become theta equals tangent inverse 1.51. So when you go to put that in your calculator, it'll look like this. Second function tan, 1.51, 56.48 degrees, okay? 56 is good. 56.48 degrees. So what they're saying is that this angle here is 50, we're just going to say 56 degrees. Oh.